Very little has changed throughout most of history with prosthetic limbs. Prosthetic hands began thousands of years ago in Greek and Roman times. They were hands made of leather and wood for aesthetic purposes only. Prosthetic hands evolved during the Civil War times to hooks, which could be covered with rubber hand shapes or other implements such as forks, knives, spoons, brushes, saws, and many other devices. Prosthetics progressively moved forward when cables and springs were integrated to help simulate actual arm, wrist, and hand movement. The prosthetic hook has been a common device since the 16th century. With the invention and introduction of the split hook prosthetic arm in 1912, an amputee was able to have more control as they would with a hand. This allows the amputee patient to grasp items and complete daily tasks such as clipping their nails. The need for fully functional hands could not be properly addressed until the age of microprocessors and robotics came into play. The invention of the computer chip and modern robotics has paved the way for the end of the mechanical prosthetic. As you can see, the work in robotics has helped doctors and scientists more accurately recreate the actual movement of the human hand. Flexibility and pressure are easily adjusted with the computer-controlled robotics. The advance in fabrication techniques of materials needed for prosthetics has led to better functioning joint mechanics. This makes it easier to create devices that, in addition to the robotics, makes the prosthesis more human-like. The technology in the early models of the iLimb by Touch Bionics has given many people the ability to do things that they had not been able to do for some time. With its 5 individually powered fingers, it allows patients to do things like type on a keyboard and fold laundry. It also incorporates a technology that the company calls VariGrip, which allows for variable grip strength depending on what is needed to be able to be picked up without crushing it. For example, this woman is now able to pick up her coffee mug and take a drink, turn pages in a book, and pick up small chocolates with ease. As modern technology has advanced, the iLimb hand has advanced with it. With refinements in design, the hand is thinner, lighter, and more lifelike than previous versions. As you can see, the hand more closely resembles the structure of an actual hand. Improvements have also led to better functionality. As demonstrated, delicate tasks such as pouring a glass of juice, picking up a small, fairly flat object, typing on a keyboard, or even doing simple tasks that most of us take for granted, such as slicing a tomato. What is on the horizon for future advancements? Limbs that are designed well enough to handle even the most delicate items such as a light bulb. The Michelangelo prosthetic hand may be such a device. The Michelangelo is one of the most advanced prosthetic hands to be designed. As you can see, the actions mimic the most basic functions of a natural hand. It also has the delicate ability to perform touch-sensitive actions like separating pieces of paper individually. In addition to the amazing ability of the Michelangelo prosthetic is the continued research into making functionality a function of the mind and not necessarily tied into the amputee's muscle structure. In 2009, scientists connected a robotic hand that is controlled by the mind and has feeling. Electrodes are implanted into the arm and attached to the nerves to stimulate the muscles and nerves in the lower arm and hand. As the patient concentrates on a specific hand movement, the electrical impulses are sent down the nerves to the electrodes to perform the functions on the robotic hand. 26-year-old Paolo Petruzio, shown here, was the first person to test the new technology, and it took him just days to master control of the hand using only his mind. The experiment only lasted a month, but scientists are already collaborating on a smart hand that can be directly implanted onto the patient permanently. What holds for the future of prosthetics? As technology advances, so does the desire and ability to recreate the human body. Will it be prosthetics that are completely implanted and operated as a normal hand would? Will it be able to be fused directly to the bone, tissue, and skin? Will we eventually get to the point where you cannot tell a real hand from a prosthetic? That, of course, would be the ultimate goal.